God is the best explanation for the beginning of the universe. Here I'd like to present a case that begins with the Kalam cosmological argument. Now, for those who are familiar with these discussions, you might say, come on, Braxton, you're not going to bring the old Kalam argument, are you again? You're darn right. I've got a personal philosophy for my life. If it ain't broke, don't fix it. And it ain't broke, folks. The argument may be stated like this. Everything that begins to exist must have a cause for its existence. The universe began to exist. Therefore, the universe must have a cause for its existence. Now, when I say everything that begins to exist must have a cause, we have zero counter examples of this principle. 100% of the evidence backs this up. And when I say the universe began to exist, by universe, I mean all of nature, including multiverses, vacuums, or anything else. If the universe had no beginning, it has existed infinitely. And without even a beginning to start from, we could never have arrived at this particular moment that we're experiencing today, because if it exists infinitely in the past and you crossed half of infinity, you still have infinity to go, and we would have never arrived at this moment. If you want a simpler way of saying it, try jumping out of a hole without a bottom to it. Not too easy.
I feel like I almost need to draw this because, forgive me for not getting it right away. So, I just put something in chat, right? I'm picturing, there's, some point. You can kind of see that in the middle. If we're talking about time, I guess we can just say that's, today. And then there's infinitely backwards and infinitely forwards. So maybe I can do some copy paste.
Look at the so now look at that series before the end point, right? The first part of that line that you drew, right? Mm-hmm. That line extends leftward, right? Endlessly. Mm-hmm. Nonetheless, if you pick any point on that line, anywhere on the leftward part of the line, on the leftward part of the line left of the end point, right? Any single one of those points, right, is going to be
put it there.
Yeah, is going to be a finite distance between that and the end point.
The end point being today, that little bar.
Being today. Yeah.
Right. So, okay, I think I get it. So if you look on the right side, from today to the future, it's that's an infinite count up. If you look
It'll never end.
Right. Mm-hmm. And if you look at this, if you look on the left side all the way to infinity, that's all, or negative infinity, whatever you want to call it, that's also an infinite count. But if you look at some specific point P, that's a finite distance from today.
Yeah, and that's going to be true of every point on the line, no matter how far.
Okay, so
there's a finite distance that traversed. And so what they want to say is that you can't traverse. If, in fact, the universe were past infinite, you could never arrive at the present. But given that every point in that series is a finite distance from the present, then it follows that it can be traversed. That's what Alex is saying.
Oh, that still weirds me out a little bit.
Well, I recognize that there's something very sort of weird and maybe even a little puzzling about it, but you see the force of the argument, right? Because it's just the case that no matter what point you pick, if you measure the distance between that point and the present, right, it's a finite distance.
Okay, so I'll tell you what I do see, and then maybe you guys can fill in where I'm missing things. So what I do see is that there's no contradiction. That's what I mean. It's not obvious to me what the contradiction would be if someone says, someone's about to snipe, and there is an infinite series of people who an infinite chain of permission leading up to them sniping. I don't see any contradiction that's entailed there. So that's Alex is actually saying, right, if there's a problem with arriving at the present from an past infinite universe, it can't be because of this argument that they're giving, because he's given an answer to it. Okay, I'm still lost.
So they might have some independent reason, right? But it's not this reason.
So, okay. Yeah, I still don't feel like I'm quite getting it. So what exactly is maybe I need to understand the objection. What exactly is the objection supposed to be that Alex is trying to shoot down here?
So they have this idea, right? Imagine the universe were past infinite. This is the intuition that they're sort of dealing with. Imagine the universe were past infinite, right?
Hmm.
How could you ever arrive at the present? In order to arrive at the present, you'd have to cross an infinite expanse, and you'd never get there because it would be like counting up.
You cut out again. It would be like counting up.
Sorry, it'd be like counting upwards from 0 or 1 to infinity.
Can I ask a question right here, actually? When you say you'd
Yeah.
have to cross an infinite distance, like when I hear cross, I think there's a point where you're on one side and then there's like a point where you're on the other side. Like if you cross a bridge, it's like
Well,
you start on one side.
the point is, if you think of time as like a moving spot, if you think of the present as like a moving spotlight or something from the past,
Mm-hmm.
like it moves forward, right? The point is that that point, the present, which is constantly moving from the past forwards into the future, right, would have to traverse an infinite distance. That's what they're saying, right? That spotlight would have to traverse an infinite distance. And since it's not possible to traverse an infinite distance, right? Because that would be like counting to the end of the series of natural numbers, right? Since it has no end, you'll always be counting. They want to say that you'll never actually arrive at the present because the distance between the present um, and everything before the present is an infinite expanse, and therefore it's not traversable. That's the objection that Gwynplaine Craig and various other people who want to contest that the universe can be past infinite are running.
So is the idea supposed to be that like the present couldn't exist because we would never have reached it?
Yes, I think it's basically something like that. We could have never arrived at the present. So we couldn't possibly be here if the universe were past infinite. We couldn't be in the present where we are if the universe were past infinite, because we would never have arrived.
Yeah, it fries my mind a little bit. I don't. I feel like
But I think a lot of people find that idea very intuitive, right? And so they think, yeah, the universe can't be past infinite, right? So they've made a lot of well, I wouldn't want to say converts. I don't know how many people were convinced of Christianity or theism, but a lot of people have been persuaded that the universe can't be past infinite because of this kind of objection, right? But Alex is offering a simple rejoinder, which is that, look, pick any point in that infinite series, right? There's a finite distance between that point and the present.
Can I just interrupt here a second? Sorry, I was
Yeah,
sure.
Stuff, but I just want to make it clear what I'm saying and what I'm not saying. So, I think the step in the dialectic is slightly one step back from the way you're characterizing it. So, for instance, I'm not saying that. So it's true that for any point in the past, in the beginningless past, it's only finitely far away from the present. That's true. So you could traverse that interval. But then, you could say, well, what about the collection of all of those points in the past?
Yeah, that's what's tripping me out right now. That's
okay.
exactly
So
it. Yeah.
The cardinality of that isn't finite; it's infinite, right? It's greater than any natural number. Because that's just saying, if you say how many natural numbers are there, well, that's not a natural number. It's greater than a natural number, and that's what we're talking about. And so the apologist is going to say, well, look, my issue is not whether you could traverse any interval along that line. It's whether you could traverse the whole line, and that you can't do. Okay, but I concede that just the fact that you could traverse any interval along the line doesn't itself mean that you can traverse the whole line. So I didn't want to be misunderstood as making that claim, because I don't think that's right. Right, so I'm not offering that as a rejoinder to that point. What I am saying, though, is if you think you can't traverse the whole line, why is that? right? And then they'll say, well, because it's infinitely long. Okay, so what? Right? Why does that mean you can't traverse it? And it's at this point that the arguments start getting deployed, which point towards counting up. And they'll say, well, you can't count to infinity. But then I might say, well, so what, right? I'm not talking about counting to infinity. I'm not talking about starting at 0 and counting to infinity. What I'm talking about is counting down, doing a beginningless countdown that ends today. And I'll say, well, look, the thing about counting up to infinity is that there are always more numbers left to count. Now that's the point where that argument doesn't apply to a countdown, because there aren't always infinite numbers left to count. There's always finitely many numbers left to count. That's the point I was making a moment ago, is we have a symmetrical looking picture, right, with infinity at either end and now in the middle. But there's an asymmetry because time moves from the left to the right, according to these A theorists. And what that means is that the end point, I am moving towards the end point, left to right direction. If the end point is the middle, where I finish my countdown, that's where I say 0. But that's just the beginning of the count up, which has no end. And once you've built that asymmetry in, right, the left to right arrow in there are some features that make it so that you can't finish a count up, which just don't apply to a count down. And all I'm saying really is, you can't just import those arguments, even if we grant them, that tell you that you can't finish a count up, to tell you that you can't finish a count down, right? Most of those, in fact, just are irrelevant. And what we're saying is, once you strip away those ones where they've fallaciously applied the arguments about the not being able to end an endless count, once we take those away, we're asking, what's the argument that tells you that you can't end a beginningless count? Right? That requires a different type of argument. It's nothing to do
okay,
not being able to finish counting. Right? That's got nothing to do with it.
Is it okay if I ask something? Because I think I'm the one who's struggling with this, because you guys seem on the same page. So what it would mean in this context to end a beginningless count is just to arrive at today, right? Like the idea is, like, if you couldn't end it, today would not exist. Like, is that at play here? Or am I not understanding?
Okay, yeah, if you like. So the analogy is time passing through infinitely many moments or something and arriving at today. That's the same as counting down and finishing at 0. Yeah.
Okay, so I feel like I have, like, in some way, like, I get some of the bigger, like, broader strokes of what you're saying. What people want to say is there can't be if there were a beginningless series of events, we couldn't arrive at today. But then the arguments that are given for that seem to be actually arguments about counting upwards to infinity, and then once you point out the asymmetry and you take away arguments, so it's all about crossing this infinite distance, and it's like, yeah, you can't complete an infinite count up. Yeah, so the idea is once you take away the any arguments that are based on, like, asymmetrical properties where the property only holds for the up count, then it's not clear what you're left with that's ruling out the infinite down count.
That's right, yeah. It's much more difficult to give an argument why you can't complete an infinite count down. Because the thing is, all of these arguments that are supposed to motivate you not finishing a count up are all to do with it's basically just this, right? Can you finish a sequence that has no end, right? Mm-hmm. And the obvious answer to that is no. But then, if all of the arguments are relying on that feature, it's going to be difficult to apply that to a sequence that does have an end, right? If the problem is all about not being able to finish a sequence that has no end, a countdown does have an end. Its problem is that it doesn't have a beginning, right? But now you need a different type of argument to motivate why you can't finish a task that has no beginning, right? It's just a completely different type of conceptual issue, right? So it's just nothing to do with not finishing. It's to do with not being able to begin. It might be more like a sufficient reason or something, but it's certainly nothing to do with the kind of endlessness question. Right? That's just not part of it. But people who don't think about this sort of thing enough fail to distinguish between the different types of infinite sequences, right? Because an endless sequence and a beginningless sequence are mirror images of each other in a certain sense, they just think that any argument that applies to one applies to the other.
Right.
But when we in the arrow of time moving in one direction, that it means that they're not really, I mean, they're kind of mirror images if you like, but moving along those have just opposite properties to each other, right? And it's not clear that you can apply all the arguments in favor, well, you can't apply all the arguments that tell you something about one of them to the other.
Okay, I think I might be actually maybe kind of getting it now. So the idea is if you talk about finishing an infinite count up, when you say you can't do that, like we do actually mean it's logically impossible. And there the contradiction would be if you say the count is endless, right? It's like when you say you finish it, that implies it's like whatever you call it, like the semantic presupposition or whatever, like it implies the negation of that proposition that there's no end to the count. It's like there is and there is not an end to the count, right? Finish infinite count up or endless count up. It's like the count is endless and it's not the case the count is endless. There's a contradiction, right? But
it's like saying can you climb to the top of a mountain that has no top? You know, obviously no, right? That's
it's logically impossible, right? Because there's actually a contradiction if you think about it, right? It's like because when you say okay, so can you finish an endless count up, right? Endless count up, I assume that means like there is no end to this count. And then when you say finish the count up, I assume that we mean there is an end to this count. So it's just there is and there isn't an end to this count. There's a logical contradiction. It's logically impossible. But then when you talk about finishing an endless count down, and I don't know if I can articulate the next part, but it's like you're not going to get one half of what you need to build the contradiction, though, is the idea, right?
Right. There is an end to a countdown, right, which is saying 0. So can you get to the end? So let's say I've been counting down forever, and I've just said 11. Now I just said 10. Now I've said 9. Like, can I finish that sequence? Well, yeah, it feels like I'm going to finish that in like 8 numbers time, right? Very, very shortly. And there's no point in the past where, though my task might be greater because I might have 1,000,000 numbers left to count, or 1,000,000,000 or 1,000,000,000,000 or something, there's never going to be a point where I have more than just some finite task left to finish. And that's different from the counting up, because if I'm counting up and I've just said 9, then I say 10, then I say 11, I've still got infinitely many numbers left to count. Even if I'm saying 1,000,000, I've still got infinitely many numbers left to count. Like, that's the reason why you can't finish an infinite count up, because there's always more numbers left to count. There's always the same amount of numbers left to count. But a count down, it's the opposite way around. With a count up, I've only ever said finitely many numbers, and I've always got infinitely many left. In a count down, I've always counted infinitely many numbers, and I've only ever got finitely many left. Right? In that sense, they're mirror images of each other. But if your problem is you can't finish it because you've always got infinitely many left, well, when we look at the count down, it's the other way around, right? I've already finished infinitely many numbers, and I've only got finitely many left. So you can't object on the basis that I've got infinitely many left, because it's false. I've got finitely many left, right?
Right.
If you're complaining about something, it must be that I couldn't have done infinitely many so far. But then we need a reason for that. And the reason for that can't be that you can't finish an infinite count up, right? It has to be something else.
Right, yeah, the reason can't be any asymmetrical feature.
Yeah, if someone wants to say you couldn't have say I'm on my hypothesis a minute ago, I was saying, imagine I've been counting forever and I've got as far as saying 10 and then 9, blah, blah, and someone might interject and say, well, you couldn't have got that far because that would have meant you'd already counted infinitely many numbers, and that's impossible. But, okay, well, that was the original claim that we're supposed to be explaining here, so why can't that be the case? Now, if they say, because you can't count up to infinity, that's obviously just changing the subject.
Yeah, right.
Just concede that you can't do that. What's wrong with my original claim? And still, that's on the table and it hasn't been addressed by pointing out that you can't finish a task that doesn't have an end. That's just not relevant. So that's why it just doesn't. I mean, we need a different type of argument there, or we're not. I don't know. I think that hopefully that's explained it anyway.
Yeah. Well, what I'm understanding from all that is it can't. Whatever the reason is supposed to be that you can't have an infinite count down, It can't be based on some asymmetrical property about counting up. Like, well, you never a count up it's like endless in the future direction. It's like, well, wait, but that's not the case with like a countdown. So it's just
Yes,
you
exactly.
can't
That's
move
right.
from the one to the other.
Yeah.
Yeah, I need to think on it more to like really like get clarity, but I get the idea.
Well, let me confuse you further then. So,
Sure.
with an infinite count up, it's true that you won't finish an infinite count up. Obviously, trivially true, right? Because there is no end point to it.
Right.
On the other hand, it's possible that you count all of the numbers, or at least every number, right? Because, I mean, if you start counting now, then in principle, there's no number that's so high, no natural number so high that you couldn't count to it. Like, in principle, obviously you'd die before you counted to any even reasonably large number, but let's just forget everything contingent, logically contingent. Just, is there any contradiction in supposing that you count to, some natural number n? And the answer is no, right? It's logically possible that you do that.
Mm-hmm.
But then, if for every natural number n, it's possible that you count that number, you can just kind of generalize that and say, well, that means that the entire set, each and every element of that set is such that it's possible that I count it. So, in a sense, you can count all of the natural numbers. You can sort of, but now we've got to be a bit careful, because, like, what does completing count up mean? Does it mean you get to the end? Well, no, obviously it doesn't, just because there is no end.
Well, right.
But can you complete it in the sense that is it possible that you start counting now and count each and every number? Well, the answer to that just seems to be yes, right? Like, and it's not clear whether the original question is just phrased in such a way to trivialize the answer, right? Can you complete a thing that can't be completed, rather than like actually looking at, is the entire sequence traversable? And it kind of is. I mean, even with the countdown, right? Like, each number is such that I could have counted down from it, and that generalizes over the entire set, right? So it's hard to see why you should resist the claim that the whole sequence can be traversed, right? So I was edging away from that to begin with, but I'm putting that forwards now as a way of confusing things, because it just seems like once you've taken away the stuff that we were talking about before, that confusing dialectic about ending an endless thing, and look at it on its own terms. And this is how mathematicians would look at it, I think, at least the ones that see it the same way as me, I guess. But that it's not clear really that there really is any like objection that doesn't like collapse into one of these kind of misrepresentations of the question or something. So I think it's very complicated, but I certainly think there's nothing like clear to be said about any of this. None of the objections suffice, and we should just remain agnostic, effectively, about these questions. Whether infinity can be passed or not, or whether the past could be infinite. We should just be agnostic about them, because you can just diffuse pretty much any claim on either direction, and that's my view, I think.
So I'm just I hope it doesn't annoy you for me to go backwards, but there's one part that is really like sticking out to me as like this is like the part I'm not getting about what you're saying. Well, at least a part.
Okay.
So when we talk about it's not possible to traverse an infinite distance or an infinite amount of time or something like this, someone says that's why the universe can't be past infinite, because you would have had to traverse an infinite amount of time to get to today, and that can't happen, so today wouldn't exist, but today does exist, so the past can't be infinite. What exactly is the reply to that? You want to say it's not that you would have had to traverse an infinite distance?
No, I'm not. So if someone said that to me, I would ask them why you can't traverse an infinite distance, and then they would probably tell me that something like you can't count to infinity, and then I would explain that that's not relevant to whether the past is infinite or not, because as we talked about before, what's relevant is a count down, not a count up.
Right. Okay. So I think that I'm expecting too much from you here. I'm doing what I think the theist does. Actually, I'm going like, can you give me a picture of this that makes sense? But that's not really. You're not going that far. You're just saying it's not clear that there's an objection that goes through that establishes this is actually impossible. Would
That's
that
right.
be fair?
That's right. Yeah, yeah, yeah.
But he has an independent positive argument that he gave.
What's that?
This idea about you can generalize from the fact that for any given number you can count to it, that applies to the whole set.
Yeah, okay, that's right. So I think in that sense, then, it is possible to count to infinity, but we have to understand what we mean by count to infinity carefully. But I think once you do that, then there's an unassailable logical argument there, right? The premises being something like, it's possible that you start counting now and never finish counting, right? And then I say, if it's possible that you start counting now and never finish, then for each natural number n, you will count that number. And then if for each natural number you count n, then something like you will count infinitely many numbers. And if that's what it means to count to infinity, to count infinitely many numbers, then it seems to follow from those premises. And I think each of those premises are true. So it seems that, that conclusion I stand by. Now, someone might say that's not what it means to count to infinity. Fair enough. If what they mean by counting to infinity is finishing, saying the last number in the sequence, well, obviously I don't think that's possible. But, so I'm making a subtle point here. You can count infinitely many numbers, and if that's enough to qualify as counting to infinity, then I think that's true. I think that's possible.
Wait, and why do you say count infinitely many numbers? How is it that you're counting infinitely many, and not just some large finite amount? Like, why is it not an arbitrarily large finite amount, I guess, is what I mean?
Because it's every number, each one of them. And the cardinality of the natural numbers is Aleph 0. That's not a natural number. That's the first transfinite number. That's actually infinitely many. It's not an arbitrarily large natural number. It's greater than any natural number.
Okay, let me try to just recapitulate the dialectic in my head. So, someone says the universe can't be past infinite. You say why? They say that would require traversing an infinite amount of time. And you say, okay, let me grant that. Why is that impossible? And then it's just not clear what the fuck the argument is, and most of the arguments that are given seem to talk about counting up to infinity.
That's right. And then what Jack was bringing up is that I've got a positive argument for saying that you can count up to infinity. So an even stronger pushback, which is if they say, I'll say on the one hand, okay, at best you're telling me an argument which means that you can't count to infinity, but what we actually need is an argument why you can't count from infinity, and we haven't heard that. But even still, let's just, even though it's not necessary, I would push back against the claim that you can't count to infinity on the basis that I would distinguish there's no ordinal number, which is the last one in the sequence of counting up. But if you just count and never end, then the cardinality of the numbers you count would be infinite.
Okay, I just want to understand that last point. So I think I got the first part of the dialectic, and now I'm just confused by this stronger point. So,
okay,
okay.
So I think I have a way of communicating it, although it's really Alex did it already. But see, pick any number, right, in the infinite set of numbers that you could be counting to, right?
Sure.
For any one of those numbers, right, you could count to it. Pick any one, right? There's a finite number. There's a finite number of numbers that you'd have to count to get to that number. So you could count to that number, right? Well, that's just going to apply to every member of the set.
Yeah.
Okay, so the idea is just if what count to infinity means is just to be able to count to any number, then we can count to any number, or am I missing or then we
No,
can count
but
to
then
infinity?
the last step, right, is so if I can count to, so say I can count to each number, each finite number, right? I can count to that. We all agree that seems fairly trivial. But then the second step is just to say, well, how many finite numbers are there? And the answer to that is infinitely many, right? So I can count each of a set, which is infinitely big. So the cardinality taken in total, the cardinality just means the number of, right?
Sure.
So the cardinality of the numbers that I can count to is infinitely big, right? It's infinite. So in that sense, then I can count infinitely many numbers.
Right.
That's
Yeah.
one.
So the set of numbers that you can count to has a cardinality of infinity. I understand that, but then what's the now I'm trying to think of what the sense is in which you wouldn't be able to count to infinity. That's the sense where someone says
okay.
you reach the end, basically.
Okay. No. So the first premise is just it's possible, as in logically possible, that you start counting now and never finish counting. And that seems agreeable, I think. Most people would agree. Because denying that would be to say that there's some number, some finite number, which is such that you can't count past it. So obviously that's not going to be right. So it's logically possible that you can start counting now and never finish counting. And then it just follows that what Jack just said a moment ago, well, for each natural number, I could count that one. And then you just say, well, how many numbers are there that fall into that bucket? Well, infinitely many. So now look back at the first premise again. We just said it's possible that you start counting and never finish. So think about that guy and what happens to them. Well, that guy is, he is going to count 1. He is going to count 2. He is going to count 3. He is going to count n. He is going to count n plus 1, right? There's no number such that it's not true that he will count that number. So you can say of that guy, he will count infinitely many numbers. So is it possible for it to be the case that you will count infinitely many numbers, i.e. start a count up now, and have it such that infinitely many numbers are counted? The answer to is it possible is yes.
Yeah, I agree with that. I can try to just say it back to make sure I'm understanding it. If you start counting and don't stop, then you will count any natural number. So if you just talk about like the set of all natural of all doesn't make sense, but if you talk about just like this infinite set of numbers, you will count all of them. So yeah, you can say you can count, and I see this is where the language is wording me out though. I understand you'll count every number, but how do you want to phrase the conclusion? You'll count infinitely many numbers because the set has a cardinality of infinity?
Yeah, that you will count infinitely many numbers. It's possible that you will count infinitely many numbers. Yeah, that's right.
Okay.
Now, the thing to distinguish between is it possible that you will have counted infinitely many numbers? To which the answer is no. There's no point at which you can look back on that count and say, I have, at this point, I started at 0, and now I've counted infinitely many numbers. That's going to be true. But
okay.
so this is the simple to perfect tense inference, right? So people want to say, if I will, eat this apple, then it will have been that I've eaten the apple. Right? If it's true that I will eat the apple, then there'll be some point after that where it's true that I have eaten the apple. But that inference is not logically valid. It's just valid in a large but not complete set of cases. And I'm arguing that the one we're talking about counting is one of those. But here's another one, right? Imagine that time comes to an end at some point, right? The universe ends. Time is finite towards the future. And at that very last point in time, some proposition P is true for the first time ever. And that proposition might be something like, this is the end of the world or something, right? That's never been true before. It is true now, and that's the very final thing that's ever true. Now, at every previous point, it will be that P is true, right? Because every previous point is earlier than the last point. But there's no point which comes later than that.
Wait, sir, you lost me. Wait, why would it be that P is true at every previous point? Because there's previous points that weren't.
What's true at every point is this proposition. It will be that P.
Yeah, right, okay.
Right? That proposition is true at every previous point. right? But there's no point where it will have been that P is true, because P happens at the last moment of time. There's no point in time that comes after it,
Oh,
right?
that's
It's
so
not
subtle
going to
and
be the
weird.
P will have been true, right? So it just follows like that the inference from will be to will have been is
Right.
not logically valid, right? There are cases where it fails. And
Right.
the one
Yeah.
that we were talking about before, where the guy counts endlessly and his counting fills the future, is another instance of that. Because while his counting fills the future and there's infinitely many counting events in it, there's no point in the future which comes after that sequence, right? So it's not true that he will have counted infinitely many numbers, even though it's true that he will count infinitely many numbers.
Oh, that's so weird.
Right.
Okay. I think I get that actually. Right. Let me just think about the phrasing there. So, yeah, he will count infinitely many numbers, but there's no point where he will have counted infinitely many numbers,
Yes,
because
that's right.
that last, when you say it like that, that entails this like it's like further proposition that there's like some point where he counts the last number or something.
Yeah, well, there's some point after which he's counted all the numbers, yeah. And there is
Right.
no such point in time where
Oh,
that happens.
those things sound so subtle. And see, I didn't track a lot of the paper. I know there's multiple papers, but the one that I read, I didn't track a lot of it. It's probably obvious why from this conversation. But like I remember that you kept like correcting Craig on this, and it was like very, very subtle. But now
Yeah,
I
well,
think I kind of see what you're saying.
Craig didn't follow it either, I think. But, subsequently, I wrote this up into a paper that was accepted in and is coming out shortly in the journal Mind.
Yeah, congrats,
is,
man. That's
you
so
know,
cool. That's
top
really
paper.
great.
So that's, I can send you, well, you have that, but so this is peer reviewed in the highest level. So it's fine that Craig doesn't understand it, I think, anyway. I'm not saying that it's like unassailable, but like it's he dismissed it on the grounds of well, his dismissals were short of the mark, let's put it like that.